Hey guys, welcome back to my channel. Today I wanted to return to some more science-based content, and I had read a couple of books while I was prepping for What is Reality and Hacking Reality, and I really love both of them, and there were some ideas in both books that really piqued my interest, and so I thought today I would do a little book review discussing those ideas in this video. And if I ramble on too long about the first book, I might end up splitting this into two videos, so we'll just see how it goes. And if you're into science and astrophysics and space travel, then you're probably well familiar with both of these books, but I think that there's so much interesting stuff in both of them that I think it's worth a second look, even if you've already read them. The first book is Neil deGrasse Tyson's Astrophysics for People in a Hurry. I think this book came out in 2017, and this book is exactly what it says it is. An overview of all things related to astrophysics in an adorable, nearly pocket-sized little book. He talks about planetary science, general relativity, and my favorite, dark matter. And it's all done in about a dozen chapters that are like 12 to 20 pages each, so he definitely packs a lot in. One of the quotes I love about the book, and I thought a lot about when we were filming What is Reality, is that he talks about astrophysics as being the bleeding frontier of knowledge, and I love that. And I felt that that was sort of the theme of both docs as we were filming them, coming right up to our frontier of knowledge and then sort of questioning, speculating, theorizing, and testing, and then hopefully sort of watching that frontier of knowledge slowly seep forward. He also discusses two of the big modern discoveries in astrophysics, one being Einstein's general theory of relativity in 1916, which I like how he sort of defines as a theory that gives us our modern understanding of gravity, in which the presence of matter and energy curves the fabric of space and time surrounding it. I like how bite-sized that explanation is. It's just put that in your pocket. Great, thanks. And the other one being the discovery of quantum mechanics in 1920, which is sort of our modern understanding of all things small, molecules, atoms, subatomic particles. But what really struck me when reading the book is how recent those discoveries really are. Like 1916 and 1920, it's not that long ago, you guys. I mean, there are people who are still alive today that existed in 1920 and probably 1916 too. Is that right? Kane Tanaka, born in 1903, he's 118, you guys. Kane, our friend Kane here, was in high school when Einstein was like, hey, you guys. Oh, it's Tanaka, Kane Tanaka. Sorry, Kane. Anyway, that's an example of the bleeding frontier of knowledge that I think he was talking about. I mean, those discoveries, which feel very seminal in science, were only 100 years ago. So 100 years from now, who knows what's going to be discovered, and it's so exciting. I also learned in the book that the word galaxy comes from the Greek word galaxias, which means milky, and our galaxy is the Milky Way. Ding! Just saw what they did there. But the thing I enjoyed the most about the book was the chapter on dark matter. I'm a fan of dark matter, if such a thing is possible, and all of its fascinating yet irritating unknowables. I like in the book that Neil deGrasse Tyson describes dark matter as a frenemy, which I think is hilarious because he says it's annoying, but we need it. And basically he starts off the chapter by kind of defining this why in dark matter. That's the big thing about it, is this why. And he kind of describes it as by saying, we've now been waiting nearly a century for somebody to tell us why the bulk of all the gravitational force that we've measured in the universe, about 85% of it, arises from substances that do not otherwise interact with our matter or energy. Or maybe the excess gravity doesn't come from matter or energy at all, but emanates from some other conceptual thing. In any case, we are essentially clueless. And then he explains this story about the Fritz Zwicky escape velocity conundrum of the coma cluster, which is a mouthful, to further kind of explain this mystery of dark matter. And I thought this was really interesting. I hadn't heard this story before. Basically, Fritz Zwicky was an astrophysicist at Caltech in the 1930s, and he was studying the movement of individual galaxies within a titanic cluster of galaxies known as the coma cluster, which is about 300 million miles away from Earth. And using the motion of a few dozen galaxies as tracers, Zwicky discovered that the average velocity was really, really high, like shockingly high. So high that it was higher than the escape velocity for the cluster. And escape velocity, as you can probably guess or know, is a speed that a planet can reach where it essentially breaks its orbit around the sun because it's going so fast and leaves the galaxy. So thus the conundrum. How could the velocity be so high and yet this cluster wasn't going anywhere? And this is where dark matter enters the picture. What is this unknown, invisible, yet powerful missing mass that was binding clusters like the coma cluster together? Another force was affecting what was happening, but we couldn't see it. Eventually, the missing mass became known as dark matter, but it's not simply matter that is dark, it's something different altogether. It has 6 times the gravity of all visible matter, but it cannot make nuclei or molecules, and it doesn't absorb or reflect light. It doesn't interact with electromagnetic forces. And yet he talks about in the book the essentialness of dark matter. So there are these 2 competing forces in the universe, gravity and expansion. And gravity wants to coagulate the universe and expansion wants to expand and dilute it, sort of the constant push and pull going on in the universe. But Neil deGrasse Tyson points out that gravity from ordinary matter couldn't win this battle in the push and pull of the universe. It needs dark matter and its gravitational strength to do some of the heavy lifting. But of course, that doesn't tell us what dark matter is, only that its effects are very real and very measurable, but we don't know what's causing it. I think in the book, Neil deGrasse Tyson even says, is dark matter even matter? It's this really interesting mystery where we know something has a powerful effect, but we have absolutely no idea what it is. And I find that super, super interesting. Okay, so now that I've gone on and on about dark matter, but you can see my point. I mean, that chapter is only 20 pages, maybe less, but it's jam-packed and filled with a lot of interesting ideas and stories. And there's also a really good chapter on dark energy and invisible light. It's also really good. So I think it's a great summer read, travel read, potentially. It's one of those books where I found myself reading it a lot and going, what? And then immediately going over to Google to find out more about whatever he was talking about. And I think for me, that might be a marker of a good nonfiction book. How Googleable is it as you're reading it? Okay guys, well, the ramble factor has been pretty high, so I think I will save the book that I was going to talk about today for my next video. But if you have read this book, Astrophysics for People in a Hurry, I'd love to hear your guys' opinions about it and what chapters you like or what concepts did you enjoy finding out about or learning more information about. Feel free to give me your thoughts in the comments below, and I will see you guys in the next video.